minerals have become a focal point of competition among nations, and, in some cases, have become a part of geopolitical competition. In order to advance the transition to green energy, European and American countries are teaming up to build domestic supply chains for critical minerals, with increasing the supply of raw materials necessary for energy transition and improving their productivity as common goals, while attempting to decouple from China. With the United States and Europe already beginning to establish their own supply chains for critical minerals, uncertainties in the global supply chain for critical minerals are also increasing. The collaboration between Europe and the United States makes the issue of global energy security even more significant. In the future, Chinese new energy enterprises will need to increase their investment and maintain technological leadership, so as not to be strangled in the technological field by Europe and the United States. First, let's take a look at the development of energy storage in China. I will now report to you the trend in the development of energy storage in China. Pumped hydro storage certainly accounts for a large part and has a history of many years, but it is still not enough. The basic foundation of China's energy storage is pumped hydro storage plus coal power plants. On top of this foundation, China is currently focusing on the development of electrochemical energy storage, also known as new energy storage. Currently, the mainstream in new energy storage is lithium iron phosphate. However, it is important to note that some have calculated that lithium resources are scarce in China, and lithium, nickel, cobalt, which are essential for fast charge storage, must use rare metals. The industry concentration of these metals is even more concentrated than that of oil, and is concentrated in the hands of a few countries. This means that competition is even more intense and fierce, and the game of critical mineral supply chains has long begun. Therefore, lithium-ion energy storage will ultimately not go far, as it has inherent issues. This is why CATL, Contemporary Amperex Technology Company Limited, is desperately trying to develop sodium-ion batteries. This is because sodium, as an element, is abundant in the Earth's crust and is widely available, but sodium-ion batteries have significant problems. Their cost is only about 30% lower than lithium, and their energy density is not high enough. They can only be used in low-speed two-wheeled electric vehicles. Therefore, if you look at CATL now, they are not emphasizing sodium-ion batteries much, and seem to be somewhat silent on the matter. So, the development trend in the field of energy storage can be summarized in 3 points. Firstly, extreme safety. Secondly, long-duration energy storage for weeks, months, and across seasons. Thirdly, reducing the overall life cycle cost. If these 3 points are met, then flow batteries, especially an all-vanadium flow battery, are more mature. Why do flow batteries have the ability to challenge lithium iron phosphate and lithium-ion energy storage? Firstly, flow batteries are extremely safe as they use inorganic salt liquids, so they do not pose the risk of fire or explosion. Even though their energy density is slightly lower, they can be stacked and are relatively safe. Secondly, they have a low overall life cycle cost. Even after 20 years of use, the electrolyte remains at 99% or 98%, similar to new, so it can be continued to be used or sold. Many commercial models for flow batteries now involve renting electrolytes, so you do not need to purchase them. When you need to use them, they are delivered to you, and when you are done, they are taken away. This is simply a genius design. The initial investment may be high, but the overall life cycle cost is low. Additionally, they are not choked by, for example, iron-chromium flow batteries or all-vanadium flow batteries. The core elements of these energy storages are abundant in the Earth's crust, and China has the world's largest reserves and production of vanadium. Sichuan's Panzihua is known as the vanadium titanium capital of the world, and China will not be choked at its roots. This is the underlying logic for China's development of flow batteries. Although the current cost is high, it does not matter, as technological advancement and scale will drive the cost down. This is why the Chinese government has excluded ternary lithium batteries from large-scale energy storage because they are indeed not safe and are prone to catching fire. As Europe and the United States accelerate their transition to green energy and a green economy, the demand for critical minerals such as lithium, nickel, copper, cobalt, and rare earth elements will surge in the future. These critical minerals are increasingly being used in the development of new energy sources, the production of electric vehicles, wind turbines, and the electronics industry. Access to critical minerals has become an important raw material for transitioning to new energy sources. Therefore, critical minerals have become a focal point of competition among nations, and in some cases, have become a part of geopolitical competition. In order to advance the transition to green energy, European and American countries are teaming up to build domestic supply chains for critical minerals, with increasing the supply of raw materials necessary for energy transition and improving their productivity as common goals, while attempting to decouple from China. The Critical Minerals Intelligence Centre, established in the UK last year, issued a warning that as the UK transitions to a green economy, its demand for critical minerals such as lithium and nickel will surge. However, the UK faces a high supply interruption risk for 18 critical minerals, leaving its economy in a vulnerable state. Recently, the UK and Canada signed a cooperation agreement to jointly promote and deepen mutual participation and cooperation in the field of critical minerals. Meanwhile, the United States and the European Union are set to establish a buyers' club for materials required for clean energy transition, with the main goal of ensuring that developed countries can reliably access critical minerals and preventing disorderly competition among them for these minerals. European and American countries aim to use protectionist policies to break China's clear advantage in the critical mineral supply chain. However, decoupling from China presents significant challenges for Europe and the US, with high costs and consequences. China dominates 90% of the world's gallium, 78% of rare earths, and 79% of silicon. In addition to critical mineral supply, Chinese new energy products such as electric vehicles, photovoltaics, and wind power equipment currently hold significant positions in the European market. In the electric vehicle sector, Europe is one of China's main export markets for electric vehicles, and in the photovoltaic sector, Europe is also the largest market for Chinese photovoltaic products. However, apart from rare earths, China's share of critical mineral resources is not particularly high. A report by the Brookings Institution in July 2022 stated that China's global shares of key resources are 68% for nickel, 40% for copper, 59% for lithium, and 73% for cobalt. China also holds 70% of cathodes, the most important battery component, accounting for about half of battery manufacturing costs, 85% of anodes, 66% of battery separators, and 62% of electrolytes globally. Furthermore, China possesses 78% of the world's electric vehicle battery production capacity, with these batteries being used to assemble battery pack modules, and it also has 3/4 of the world's large lithium-ion battery factories. Currently, Australia and Chile account for over 70% of global lithium production. The Democratic Republic of Congo, DRC, holds nearly 70% of cobalt production, and Indonesia is the largest source of nickel, accounting for over 30% of the global share. In terms of copper mining, Chile and Peru collectively account for over 40% of the global share. The report's analysis suggests that China holds a clear advantage downstream in global critical minerals, controlling the manufacturing of electric vehicle batteries, wind turbines, photovoltaic cells, energy storage, and power transmission. China is effectively leveraging its advantages to optimize the critical mineral product chain, continuously leading in the processing and development of raw materials and products. The product chain is the foundation and core of the circular economy industry chain. As European and American countries have begun to establish their own critical mineral supply chains, the uncertainties in the global critical mineral supply chain will increase. The grouping of Europe and the US makes the issue of global energy security more significant. In the future, Chinese new energy companies need to increase investment to maintain technological leadership and avoid being strangled in the technology field by Europe and the US. At the same time, Chinese companies need to continuously expand into new markets, maintain existing industrial chains, promote diversification of existing supply chains, increase product value, and extend the product chain. Although there are still a large number of unprocessed critical minerals globally, the cost of mining and refining them into usable products is extremely high, not only presenting technical challenges but also consuming high energy and causing serious pollution, Bloomberg recently reported. An article on the Foreign Policy website of the United States stated that the U.S. Department of Defense has always advocated for increasing stockpiles of critical minerals. However, the U.S. not only faces regulatory and legal obstacles that have hindered the development of the mining, production, and supply chain industries for decades, but also disagreements between politicians, regulators, and environmental organizations, making it difficult for the Pentagon to go it alone. Developing clean energy is a major policy measure for the United States, especially the Democratic Party, to address climate change. However, the development and smelting of critical minerals, especially mining and smelting related to rare earths and lithium, are typical polluting industries. In the process of global industrial transfer and international division of labor in the past, the United States transferred a large number of resource-consuming and heavily polluting industries to developing countries. Now, the U.S.'s attempt to revive mineral development and production domestically may lead to policy contradictions. Balancing industrial pollution and energy transition goals is also a huge challenge facing the United States. In addition, the United States also faces coordination issues among its allies. As long as one or two countries within the small circle are unwilling to decouple from China, the U.S.'s planned supply chain alliance will fail. This will also give the Republicans ammunition. Therefore, from a domestic political perspective, the U.S.'s plan is not cost-effective. Experts say, overall, regarding critical minerals, the U.S. has painted a big picture, which is difficult to achieve its goals. Experts believe that the U.S.'s actions regarding critical minerals are a further manifestation of the trend of anti-globalization in the U.S. In recent years, in multiple fields such as semiconductors, electric vehicles, and biomanufacturing, the U.S. government has tried to ignore the global division of labor and, based on geopolitical strategic needs and alliance relationships, attempted to build a value-based supply chain system. The U.S. Congress has also continuously proposed many bills related to reshaping and de-Chinifying the supply chains in these areas, attempting to further institutionalize and frame these actions. These practices not only violate economic laws, causing efficiency losses, but also run counter to the trend of economic globalization. The U.S. is becoming more inward-looking, nationalist, and protectionist, which will continue to harm the open world economy and trade system, hindering global economic recovery and further growth.